Given the question, we need to find the infinitesimal rectangle area. So this is the tiny. This is the other word for the infinitesimal rectangle is tiny rectangle. The tiny rectangle possesses a length of dx and dy, which is unknown to us. Okay. Now the area is represented by d capital A. The d capital A is nothing but the area of the tiny rectangle is length into width, as you all know, dx into dy or width into length, both are same, right? Dy dx. So the answer is option A, B, C, 3, dA, dy dx, dx dy. The correct options are dA, dx, dy, dy dx, right? And this is the answer. Now we have another question. Suppose D is a region bounded by the functions y equal to x and y equal to x square. If you want to evaluate the double integral over this region using the order of integration dA in dx comma dy, right? Okay. What are the limits of integration? Yeah, okay. Now, given the functions from above are let's find out the point of intersection between the curves first. After finding the point of intersection, we will plot the graph and we will find the limits of integration. Yeah, okay. X y equal to x, as we all know, and y equal to x square here. X square equal to x. Take out the common part, which gives us 0 comma 1. The fourth functions intersect at 0 comma 1. let's draw the region between the curves to find the limit of integration. Okay, the graph for y equal to x is like this, and y is equal to x square. Okay, it goes from this side. We'll okay, this looks better. Now this is the region where we need to do the integration of the double integral, right? Okay, now let's take the strip in, this is dx, means we have to take the strip in horizontally. If it is dy by dx, then we can take the vertical strip. Now the strip, Okay, yeah. Here, the first part is dx, right? So to represent dx, we have to draw horizontal so that this strip is dx now, right? Okay. If it is dy by dx, then you have to draw vertical part and you have to mention dy. The function here is y equal to x. This is the function y equal to x square. So point of intersection 1 comma 1, 0 comma 0. Okay, understand. This is the region now. As you can see, the what horizontal strip varies from here left hand part to the right hand part. Left hand part graph intersect with the y equal to x, right? So limits the limits of integration are for the x part, which is y less than or equal to x, comma x equal to root over y. When if you want value of x here, the square part will go to the square root part, which gives us square root of y. The the x part is going from y to square root of y, left hand part to the right hand part, and this strip is covers the horizontal part. Now to find out the limits of integration of the y, we have to move the strip up and down from the where the region starts and where the region ends. The region starts at 0, y equal to 0, and the region goes up to y equal to 1. So the limit of integration will be y equal to 0 to y equal to 1. This is the limits of integration. So they have given in terms of words to represent the limits of integration. The lower with respect to you are the shadow to my the lower with respect to y is the lower with respect to y means the lower limit of the y, okay, is y equal to 0. You can see here lower limit is y equal to 0, the upper limit is y equal to 1. Now copy this. The upper limit with respect to y is y equal to 1, right? The lower with respect to x is x equal to, right, x equal to y. The upper limit is x equal to root over y. Yeah, I hope you understand. Happy learning. Thank you.